Okay. I mean, if you want, you can even turn off your camera and go on camera later if you want that, because we just still have time. Look at that, go on the camera. Okay, you want that, and we still have time. So keep it that way. The poster is looking very good. So we are live, everybody. So which is good. We should be starting in 5 minutes. So we are live a little bit. So we should start in minutes. So my recommendation will be, if you're not speaking, just be on mute. Otherwise, we'll get some background noise. But I think otherwise, it's looking good. Okay, everybody, we're about to start now. So we have all of you on the screen. So maybe in another 2 minutes, we should be good to go. So over to you, Vinay, from this point.
Excellent. I think we have another 2 or 3 minutes. Should we just wait for 3 minutes? Right.
Yeah, Vinay, we have 2 minutes, but you can move.
Yeah. Okay.
The voice is great. Everything is focused now, so it's perfect. Excellent. Yeah. Audience in it.
Thanks, Robbie. Just give everybody another couple of minutes before we get started. Just checking to see. I see Brant here. See Larry. See Charles. See Michael here as well. Not in breaking. Great, thank you. Okay, another minute and we'll get started. Ooh. Okay, starting we're at time. Ravi, are we good to start? Okay. Hello, everybody. Thank you for joining us on this AI for Food webinar series. Our topic for today is AI in smart manufacturing. And just a quick intros from our side. And first of all, thank you for joining us. This is an exciting series to be with. We had a safety AI in food safety webinar before this, and we had a Cheese GPT webinar. And we'll have more interesting and exciting webinars in the future. But this one, I think, is the most important webinar in our times in terms of setting the tone for bringing back manufacturing here in the U.S. And in that, just a quick round of introduction. My name is Vinay Ganti. I'm the founder and CEO of BCD iLabs, where we're building AI-driven platforms for the food and manufacturing industries. Our vision is really to transform R&D and manufacturing processes, and leveraging AI. Obviously, in today's day and age, we can't do anything without AI. So leveraging AI to be able to do that. I'm also the co-founder for the AI for Food Global Initiative, and a co-author along with Ravi and Michael. You'll hear about them, for our book, The AI for Food Movement. Again, thank you everybody for joining. I will, before I introduce the panelists today, what I wanted to do is, first of all, welcome our innovators and future shapers here in the audience to this really exciting webinar. And I want you to start putting your thought process in to imagine where factories really run smoother than your smart home. That kind of smartness that we're able to bring into our personal life is transcending into the shop floor, where we're exploring a realm where machines aren't just following orders. They're not just directly working on our instructions, but really enabling. They're enabled for decision making, and a few of these tactical decisions themselves. What would that world look like? What would we have to think about to make that world happen and live in that world, and control that world, right? So think about that. I will also dive into how AI is transforming assembly lines and together with IoT, creating a social network of machines on the plant floor, in the network, with plenty of data sharing. So there's a lot of data discussions that happened. Think about edge computing, truly the factory's own superhero, right? And in its ability to process data, its ability to enable all of these AI things, AI that we were talking about, and how a smartphone, helps with a lot of task management, some of them autonomous. How a system on the plant floor can be very similar to that. How can it anticipate? How can it solve problems? How can route read off things that even before they occur? And a lot of these things, when we talk about smart manufacturing, we we think a lot about robots on the factory floor, but from robots to cobots, it's working alongside humans on quality systems, on computer vision based systems, and assisting humans in doing what we need to do to make our factories more safer, more productive. And we're not just talking about robots and what they do. We're also looking at the efficiency and precision that factory floors today need. Um, and if in the audience you're a manufacturing maven, or somebody who thinks digital twin is just another fancy name for things we've done in the past, it's all fine. I mean, we welcome each and every one of you to be a part of this journey, because we need many different points of view. But we also, before we get into the session, also want to invite you to go, look for our book, The AI for Food Movement. It's available on Amazon. It gives you some perspective that Robbie, Michael, and I kind of put together to what should this look like, specifically around food, food production, food manufacturing. So with that, what I would like to do is introduce our esteemed panel today. And in introducing the panel, what I'd like to do is first, I want to introduce Brant. So Brant Nystrom is with Lexmark. He is responsible for the Opera Edge, Lexmark's own Edge line. And his expertise lies in IoT and analytics, and specifically on our solutions for retail and manufacturing environments. He is really skilled in designing and implementing complex AI systems, cloud infrastructure, data visualization, also with a strong background in technology management and new product development. And then Laddie comes to us as the head of digital, a really critical role, a newest role at Baldwin Richardson Foods. He's truly driving digital transformation across the entire IT ecosystem. And before BRF, he was the principal at Advanced Manufacturing International and various leadership roles at Praxair. And Larry has been very active in the manufacturing industry, in advocating for smart manufacturing, for digital transformation. And he's also serves on the Smart Manufacturing Executive Council and on the board and the Manufacturing Leadership Council, and a contributor as an advisor to the University of 𝐷𝐞𝐻. Then we have Charles. Charles comes to us from Microsoft with loads of experience and passion for innovation and growth. As a venture partner at one Apeiron and coach for the Founders Institute, he truly empowers entrepreneurs to build at scale their business globally. He's got a strong focus on talent development, and really is focused on hiring and developing top tier talent. He's also on the advisory boards of multiple startups with a really deep understanding of operational excellence, strategic planning, and business growth. Charles holds a degree in systems engineering from the Metropolitan University, Caracas, and has an advanced education from Harvard and Columbia Business Schools. And last but not the least, our own Michael Walton. He's our co-founder at BCD iLabs, co-author for AI for Food Movement. Michael is also on the board of 𝐶𝐸𝐺, the Institute of Manufacturing, with various leadership roles that he's held. He's head of manufacturing at Google, globally, or manufacturing executive at Microsoft, and has helped multiple Fortune 500 to Fortune 100 clients through his experience. He's also an expert in driving digital transformation, agile manufacturing, and building resilient supply chains. Michael is also truly passionate about innovation and guiding organizations through complex technological challenges. So with that background, I'd like to give the floor to Brant. Brant, the floor is yours.
Thank you so much. And good afternoon to everybody. Very happy to be here. My name is Brant Nystrom. I'm a Lexmark laureate and portfolio manager for our 𝐷𝐸 product line. And yes, that's right, Lexmark, the printing and imaging solutions company. We are not only a large-scale global manufacturer ourselves, but deeply engaged in new offerings around IoT and edge computing. I've served many roles in my time here at the company over the past 28 years. The majority of my time has been spent in research and development, program management, and new venture creation. One of the businesses we've developed here is the Lexmark 𝐷𝐸 computing platform. I'm now the portfolio manager for that, and it really drives my latest perspective into smart manufacturing technology. Here we go. Okay. With 𝐷𝐸, and I'll talk a little bit about that as it is really what colors my view into manufacturing space. We combine edge computing hardware. You see example there in the chart. Modern vision AI applications and advanced device management capabilities to help drive the promise of AI into business operations. Our work is highly focused on the simple and efficient deployment, scaling, and management of edge AI-based solutions for a variety of industries, including manufacturing. We place efficient, cost-effective edge processing devices, which you see there, in situ within manufacturing environments to extract operational insights and drive actions, alerts, and notifications. We don't do this in a vacuum, however, but in conjunction with existing MES systems, cloud-based analytics engines, and other business-aligned systems of record. Much of our work includes environmental data extraction, system and process optimization, workplace safety, transportation operations management and tracking, and many, many others. We operate a broad ecosystem of technologies and partners in our ongoing efforts to support a wide variety of edge-based visual AI solutions. A few of those partners are joining me here today, and edge computing and visual AI don't operate in a vacuum, but really as a supplement to other existing systems that technology stacks to hyper-optimize manufacturing environments and streamline operations and processes. Next chart, if you will. So more specifically with regard to the manufacturing industry itself. So smart manufacturing principles and design have had a long history with an amazing evolution of capabilities. I remember, like, as a boy, my father was involved in bringing factory robotic automation to the German auto manufacturing scene, and later creating educational programs in academia for advanced manufacturing and integrated manufacturing systems, many of which are still in place today. But really, in bringing us back today, the needs of the manufacturing environment are simple and haven't changed, right? Performance drives efficiency, and efficiency of systems and processes helps to balance the ratio between cost and quality. Our manufacturing customers, as well as our own manufacturing operations, endlessly deploy new and innovative technologies, digital platforms, and data extractors of all scales, from large to small. Many of our large-scale systems are powered by the tech wares of my co-presenters here and our friends at Microsoft, while we and our friends at BCD iLabs focus more on smaller-scale spot solutions to solve more specific and connective tissue types of problems. And of course, today, we're all aware of the promise that AI brings to all aspects of our business operations, from the immersive virtual worlds of the metaverse, omniverse, and mesh environments, to the deployments of LLMs and VLMs, kind of the middle ground there, and down to visual AI applications custom built to solve a specific business critical use cases. But the great news in all of this is that we're really in a time of great digital growth. So where the nearly unthinkable kind of the past is technologically solvable today in many ways. So I really look forward to our ongoing discussions here today and all the really great things that we're going to witness in the coming years.
Thank you, Brandon. And with Brand's with Brant sharing his point of view, the way we've structured this, and I should have thought of this out as well, as we've structured this with each of our speaker sharing their point of view on what AI in smart manufacturing means for them, for their company, a combination, and then we're going to open up, a panel discussion here, and then room for part, your Q&A as participants. Okay. So with that, thank you, Brant. Let me hand this over to Larry. Walk you through. I'd love to hear your point of view as well.
Yeah, thanks. Hi, everybody. Really happy to be here this morning, this afternoon. Appreciated the chance to talk about what we are doing at BRF, the smart manufacturing in general. So, Baldwin Richardson Foods is a privately owned, medium-sized food manufacturer based in upstate New York. And while you may not have heard of us, you have heard of many of our key customers like McDonald's and Starbucks and Dunkin' Donuts. And so we are a key supplier for them. I come at this from the BRF perspective. I oversee all of our IT systems and infrastructure across the organization, as well as lead our digital transformation efforts across all functions within the business. So if you want to jump to the next slide. So again, I come at this from the manufacturer's perspective, having spent my entire career working for and with manufacturers of various different sizes, right? And so different perspectives around the art of the possible, whether you're a large manufacturer, medium-sized or small like us. At BRF, we are, as I said, a really rapidly growing organization, and we see the digital transformation of our business, of which AI is a piece of, is really being foundational to what we want to accomplish as an organization as we grow going forward. When I speak to audiences, I typically end up these days, having been in this space for a while, talking less about technology and what do you have to do for an organizational perspective to really drive value and really move the needle in this space. And so a couple of areas that I focus on are some of those key things that I highlight on the top of this slide, really organization, vision and mission, leadership, etc. Right? What are all those pieces and parts that you need for the organization to be successful? And then on the other bottom half of the slide, it's really making sure that you can do all the pilots that you want, whether it be in AI or other spaces, but if you are not securing your foundation of technology, of infrastructure, of capability, of security, then you will not be successful in really driving value at scale. And so hopefully we'll get a chance to talk about these two elements a little bit as we go forward. Next slide, please. And then finally, just to give you kind of the way I think about AI and AI maturity, again, we are coming this from a company that is relatively new in the digital transformation, our digital transformation journey. And I've been in larger companies before where we've been further along, but in the case of a company like BRF, how do we kind of evolve up to that maturity curve in AI? So it kind of starts with, to me, AI becoming embedded in the end products, where we don't have to have a huge amount of internal expertise, but we can leverage that capability. And I will talk about an example of that in a second. From there, how do we start to use some of these new tools, Copilot and ChatGPT, et cetera? And how do we start to build capabilities within our organization to build individual productivity? And then finally, the final step or the next step after that is, hey, great, now that we've done that, we have some smarts, we understand the puts and the takes and the guardrails, and now we can start to drive some real applications internally that may actually differentiate us from a competitive perspective. And so kind of in that early phase, the bottom half speaks to one of the solutions that we have implemented, which is around machine monitoring. It's from a company called Augury. It's a very, I will say, it's part of this whole emerging portfolio of predictive reliability technologies, where you have a packaged solution that measures data, in this case, vibration and temperature. You use that and you use an AI engine in the background to predict the opportunity or the possibility of failure of that machine. And then there's actually a collaborative platform where we can directly communicate with real experts in their back office and really identify issues with machines and really bring that expertise to us, versus us having to have all that expertise internally. So a great jumping off point. And then, as we go further in the conversation, maybe we can talk about next steps in our AI journey. So thank you. Vinay, I think you are muted.
Sorry about that. Thank you, Larry. Thank you very much. And with that background in the soft skills that is needed, the cultural change that is needed, I think that's an area, Larry, that we'll be definitely delving into as we get into this journey and how that manifests into what we actually do. So thank you for that. Let me hand this over to Charles. Charles, for your point of view.
Yes, great. Thank you. Good afternoon and good morning as well for everybody around the US. And very good evening, anyone around the world. I lead the Azure AI infrastructure GTM across the Americas, so industrial transformation. Sorry, that is a long name for the portfolio products that include IoT operations, mapping, rendering for things like digital twins, mixed reality, and Azure OpenAI, right? So the work that we've done and the way we see this, I want to talk a little bit about why now, right? Because Vinay mentioned something about bringing manufacturing back to the US and what the key for that would be. So the key, of course, is AI. But the question is then why now? And from our perspective, the core underlying force behind today's progress is pretty much scaling laws. So just like Moore's law drove the information revolution, the scaling laws of deep neural networks and transformers that we're seeing today is what's driving AI revolution. So progress in compute was keeping up very much with Moore's law, like doubling every 2 years. What we see now is the progress in AI performance is doubling roughly every 6 months, right? So we can go to the next slide. So what that has given us pretty much is three capabilities that are coming together because of these scaling laws. First, we have a new natural interface that is multimodal, right? It means that it supports speech, images, and videos, both input and output. So that clearly now it's bringing a natural language interface to systems, to machines, and to assets, right? Second, we have memory that retains important context, recalling both our personal knowledge and data across apps and the web. And finally, we have a new reasoning and planning capabilities that helps us understand complex context, complete end-to-end tasks on our behalf, reduce our cognitive load, right? So what used to be a trained worker, think about that trained worker on the factory floor that's been doing this job for 25 years, right? We can have now all that domain knowledge, all that expertise. We can now be mathematically captured into a neural network through reasoning and planning capabilities, and we can have that in the cloud. So these three major capabilities are driving a lot of transformation right now. And when you bring them all together, we'll bring in kind of like an agentic world, right? It's a world full of agents. It's a rich tapestry, including personal agents, you can use across work, life, business process agents, cross-organizational ones. These are all laid on top of the digital systems infrastructure. So with that in place, as we think about the strategy for the intelligent factory, we pivoted around these three pillars, right? First, around connected and enabled workers. We see a tremendous opportunity to leverage Gen AI and build factory knowledge copilots that can learn from all the unstructured data that's out there in the factory floor, including standard operation procedures, health and safety manuals, and more, right? These copilots can help the frontline workers in performing their jobs more efficiently, improve their productivity, and assist them with daily activities. There's also an opportunity there to bring AI services like machine vision, sound, and other cognitive services to improve worker health and safety, right? The second pillar is around optimizing factory operations. Factory digital twins is, is a digital replica of the physical operations. They can help generate alarms, alerts, detect anomalies in production processes, define optimizations, etc. Investing in a factory data platform that can bring clean and contextualized data from the enterprise operations all the way from this CRP, ERP, CRM, as well as factory IoT systems is key for accelerated use cases on this. And these data states, of course, needs to be secured, right? In addition to IT security, OT security also becomes now key. And the third pillar is around modernizing the factory edge infrastructure, right? From our perspective, we now take an adaptive cloud approach that goes across the cloud and edge to bring the right mix of data and insights, et cetera, for our customers. The Lexmark solution that you just heard about is one of those great examples. And we also see that we have a big opportunity in migrating key factory applications to the cloud. MES systems in particular are very ripe for AI infusion and modernization. So across all these 7 tactics, you can build, from our perspective, an AI-infused intelligent factory that is built upon a secure digital platform for both IT and OT data. There.
And from Microsoft's perspective, there's a big play for Microsoft and big push for Microsoft to drive AI into everything they do. There's a big push for Copilot, and we'll talk about a lot of that and how that really enables folks in manufacturing, not just in corporate environments, to be able to leverage those investments that Microsoft has had, and what does that mean to the overall manufacturing landscape. With that, let me hand this over next to Michael.
Hello, everybody, and thank you for your time. I've been dealing with, smart factory or digital factory, so many names, for many, many, many years. And so it's a real pleasure to meet everyone and to give an opportunity to talk about this. Of course, I've helped to also contribute over the years to 𝐷𝐶𝐶 and its early founding, as well as companies like Microsoft and Google, Atos. And then I've worked with a number of food companies like Cargill, as well as Ardent Mills and ADM. Of course, some of the industrials like Caterpillar and John Deere. So it's really nice to meet you. If we could go to the next slide, please. So what I'm going to talk about out of the gate is it's foregone conclusion now that smart factory works. And so I want to talk a little bit about just one part of an industry that really is kind of the face, if you will, of many of the industries, regardless if it's process or discrete manufacturing, and some of the key trends. Now, to put some historical reference to this, the AI revolution wasn't even on the digital roadmap as a top 10 trend until 4 years ago. Ironically, it hit 7 in the top 10 from many different agencies like Gartner and other insights. But now it's been in the top 3, if not number 1 in 2024. And I suspect for the next 4, 5, maybe 7 years, it is becoming a bridge for the manufacturers of the machines to the floor, the software manufacturers, and many more that is really showing tremendous value. There's a lot underway from the AI revolution. I'll hit on that a little bit in my next slide, but some of it is being driven by the demands in the industry coming out of COVID and then into this more consumer-based, being able to drive greater personalization and hyper-personalization. I myself am a consumer, and I myself do want hyper-personalization. I can even get my M&Ms with my little boy's name on them. So if I can do that and I can get other products like that, I want them more personalized to me. And I think we're seeing a huge spike in personalized health around different products that we consume, regardless if it's food or not. And that's all the way into the high-tech industries, you name it. The direct-to-consumer, it comes up every day, it seems. And so I won't double down on that, but everything from food to beauty to all around the world, even to a point of where its point of origin comes from, to that consumer is mattering. That came up again in another conversation just this morning. And sustainability being behind everything, not just schedules 1 through 3, but making a real difference and designing in our products such that rather than capturing it in the form of just waste, trying to design in a much more improved sustainability, and whether it's water consumed waste that's produced or energy that's used in producing it. In price inflation, enough said, don't need to go there. Everybody knows this is just a constant challenge, and being able to deal with that in our internal costs. And then the skills and talent constraints. You heard the prior speaker from Microsoft talking about capturing that knowledge from workers. We are at the middle of the silver wave of exiting employees in a mass number, mostly expedited by the exit out of COVID. But now we have another age trend that's showing that we have workers that want to contribute to being able to help divulge that knowledge and not walk away with it, but they're not being given the tools to do it. So I can't say enough that the tools exist, they're cost effective, they work. I would ask you to investigate that if you are not already. And then that faster time to market is number 7. It's actually moved now into the top 5 for most industries. I suspect it'll remain top 5 for the next 5 years, maybe 4. And this is where that challenge goes. Go ahead to the next slide. Somebody hit a button. And that is in that launching new product. It's not about, can you do it so much faster? The problem is the systems internally, the technical debt that exists or doesn't exist, meaning they have nothing, and it's all paper-based, but some legacy systems in R&D, being able then to move into scale up through engineering, and then on into manufacturing it and bringing back those lessons learned into R&D from product in the field and how it performed. It's just those systems are all stovepiped. It's like the old ERP days. Why get an ERP when people were looking at ERP in the 90s, 2010s? And in large part, it's because they had so many fiefdoms in finance and HR and elsewhere. Well, now we are at that next wave. We're seeing it now for the manufacturing, from the insight and marketing to the R&D to engineering to plant manufacturing, and then capturing insights from the field and putting all that back in and keep on pushing and reducing cost and time to market, while also increasing function, feature, flavor, texture, or net new products all in general. It's just a real problem. Understand that historically, we got a real problem that the money being invested for new products is going down. So here it is, demand is going up, hybridization's going up, but R&D's investment's going down, and the speed is not dramatically increasing to bring things to market. So here at BCD, we've created a solution of Innovate OS, and that system's simply taking those fiefdoms down and using AI, being able to leverage technical debt that a customer has already without having to rip it out, and being able to work that together. Much like you heard, you can bring old MES to the cloud. You can revitalize old MES. We can help you to do much of the things around R&D. But the bottom line is being able to unlock that innovation, bringing Smart Factory to act on it, execute with the highest degree of quality and speed, and then learning all the while. Capturing that learning is what we're all about. So I would say to you, take a look at that. It's very real. And I hope that you take your journey in Smart Factory is getting underway. Thank you. Vinay?
Thank you, Michael. And Brant and Larry and Charles for really sharing your point of view. It really sets us up for the next section of our discussion. What I'd like to do is have a key topic. I want to bring in each, our panelists, maybe in groups of 2, talk about the topic, move on to the next, and we've got about 6 or 7 topics I'd like to cover, time permitting, and we'll have enough time for Q&A. So let me start with leveraging AI for predictive maintenance. So Charles, Michael, I'd like to open this up to you. How can AI spot issues before they happen? the whole premise of predictive maintenance, and how much of this really training data, loads and loads and loads of data, how does it work, and how realistic is it? What should we have as expectations?
Yeah. So if you want to start, Michael, you can share an example. So we do have lots of data being generated at factory floors, right? Some estimations say that we have 10 times more data generated in a day than what the data was used to train ChatGPT, right? So the question is about getting the right data, contextualizing, etc. Then in terms of predictive maintenance, right? When you start it, is that follows as a pattern, which is a known pattern, right? In which that asset has a behavior that's supposed to follow. It has an estimated time life, right? And all that can be modeled through machine learning models. And then you have tools like, for example, we have Azure Machine Learning, in which you can build, you can train, and you can deploy all those models to effectively predict when is it going to fail. And all of this is based because you identify patterns. You take that history that you have of that device and the data that it produces on what it used to be a good state, or what is a state in which it needs to be maintained. And then based on that, you can train it in the cloud, and based on that, just compare the actual data now to that model, and then determine when is the right time to do maintenance, or when it's the right time to change certain things, etc.
So on our end, I believe that, look, I've heard this more times than I can count, that companies, even small companies, saying, hey, we are data rich and insight poor. How many times have we heard this? And the data captures even far more now than there's ever been. So in looking at the insights within it and using AI, I would say that there are a number of things. And technology is advancing itself all along, because not all data is good data, not all data is clean data. But I believe AI, as it's advancing forward in machine learning, it's filtering out some of those that would be left and right limit. So it's a lot less of a heavy lift to pick it up these days, right? Furthermore, the GPU capability. And that state, if you start out and you're looking at whether that state needs attention or not, you'll be successful. It's when people start trying to get out of the box from day one. I want to predict when a hopper is going to need lubricant on this spinner. It's like, you're really kind of going way too detailed in the beginning. Build out that foundational success such that you're helping maintenance out on when there's a condition we know that it's going to need some attention. And as they build their body of knowledge through those conditions, the machine learning can learn from it and begin to predict that it needed oil for X part, or that it was clogged. And then based on that, you will have a high degree of success. I've watched some frustrated people out of the gate because they get over prescription rather than just simply trying to keep it simple in the beginning, because you're trying to help maintenance get that, know that there's a state and a condition for them to give it attention. You do that, you'll be successful pretty fast.
Thank you, Charles. Thanks, Michael. The next point is around IoT and data integration, how can that help in real-time decision making for supply chains? And we've all seen the challenges, post-COVID and supply chain challenges. So there's, when you're looking at a manufacturing operations, things don't just stop at the factory floor. What comes in, what goes out, how do you manage in and out? There's a lot of supply chain management there. So how does IoT data drive this real-time decision making? And does it actually help synchronize our supply chain models better, right? Our network better. I'd like to open this up to Brant, first to you, and then Charles.
Yeah.
Yeah.
Let's see here. Kind of in our world, we utilize what we typically refer to as light edge devices to create these IoT connections to existing connectable equipment. Also to create data translators as well, things that speak languages like BACnet and Modbus, any of the things folks are used to and have done in the past, to enable these systems and devices to effectively communicate with one another. And in cases where analog gauges or physical processes are involved, custom AI applications can be developed to extract functional information visually from working environments, package that data, curate it into a form that other systems expect to see, which we have mentioned here, and hand it off to larger analytics engines for long-term processing, trend analyses, and more complex operations. Generally speaking, these days, in particular with systems managed by folks and companies with a real willingness to solve problems, which sometimes is complex in manufacturing space, it's usually not overly burdensome to communicate and share data. In the past, that's always been quite difficult. Now, with these RESTful interfaces and such, it's easier to do so. But ultimately, I think the real question seems to be, what is the right data to collect, and what is the most efficient way to store and utilize that data, so that it drives action and impact to the business. So really, for us, it's like focusing on productivity, efficiency, and cost-effective solutions development. And as far as the integration piece is concerned, that tends to be a secondary process that's really kind of under the covers that we sort of like, as I always say, like let the nerds take care of, because they really do a great job these days. And we love our tech guys, and they're really great at that communications piece. But again, back to that thing of we have lots of data. What do we do with it? The real piece of it all, to me, is curating it effectively up front so that it is very easily digestible by other systems and easy to share and communicate.
Yeah, I'll probably just add a little bit to it and our perspective into how we see that. Brant talk about those light devices at the edge and the contextualization of the data, having the right data, because as Michael mentioned before, we're data rich and insights poor. So from my point of view, we want to see it at the edge on the IoT, because the IoT devices have all the data, right? So from us is, okay, let's look at an architecture that's containerized, right? That you can embrace open standards, OPC UA, MQTT, ACRI, and all those. So you can bring that into the cloud, or manage that device into the cloud. So now you have that light device on edge, collecting all the data that you want, but then also being managing the cloud, deployed, etc., and making sure that you provide the right context to that data, to that sensor, right? So that number could mean either RPMs, or it could mean temperature, or it could mean whatever it means, but making sure that it means what it has to, right? And then you can manage it from the cloud, etc. And then to your question about synchronizing the supply chains, right? Because everything Brant said is right on spot. But then yes, you want to, like, if you think about, we talk about digital twins, for example, a lot of people think about digital twins just to a copy of the physical asset, but you can have a digital twins of the process, of your whole process, of your whole supply chain. So having an insight or knowing where an IoT data or an IT device gave you some data of something that could fail or could affect the whole supply chain, if you apply then the right AI models to it, you can also know what the impact will be. You can also know how to change it, because then you can model the process. Okay, I'm not going to be able to get enough donuts from this fryer at this location, but I already have all the supply network committed, etc., for another place. So where's another fryer? Where's another factory that's underperforming that I can inject a little bit more so that I can get the produce and put it into that distribution network and make sure that it gets to them. So it's really worth it to look at this whole supply chain, integrate that IoT data into the supply chain, and also look at the modeling in the supply chain, and model the process of your supply chain into the cloud as well, not only just the physical manufacturing floor.
Yes, and Charles, to that point, one of the things I remember that in some of my past organizations we were ideating was how do we create an enterprise digital twin with everything else there? I mean, there's a lot of complexity that one can build into this digital twin concept, and how complex can we make it? So it's a very, very interesting topic. So thank you for sharing that. In about 5 or so minutes, we'll try to open this up for our audience and their questions. So if you have any questions, do please send it in the Q&A section, and we'll definitely try to get to it. So the third topic is about autonomous. It's a very loaded word, and it a lot of times you think here autonomous, like, well, what about me? Well, what am I doing? And there's a lot of human element that is inherently attached to autonomous processes. So when we look at autonomous operations, autonomous systems, what do you see is the role for these systems, for these processes? How much of a help augmentation is it to human expertise, and how much of a replacement? Where is the balance? What has been your experience? So, Larry, I want to open this up with you, and come back to you, Michael.
Yeah, sounds good. So of course, the short answer is it depends. I spent many years working in the process industries, and there we literally had process plants that you could almost fully automate for a good portion of when they were running, including starting the plants and shutting down the plants, right? But I would say when you look at manufacturing in the overall, that tends to be a little bit more of the exception than the rule, and more often than not, these kinds of things have to work in partnership with people, either because the people are supporting the decision process, the physical process, right? Whichever it is to support that. So for example, in our case, we are starting to experiment with cobots, right? We make, in our operation, we do processing and then we do packaging, right? So we have cases of bottles coming off the line, it's several tens or hundreds per minute an hour. And so instead of just having somebody at the end of the line, literally almost catching cases and putting them onto the pallets, right, and stacking them, how can we make that, frankly, easier on the people and use the automation, or in this case, like a cobot, as a means to really support them from doing those kinds of activities, right? The same goes when it goes into, for example, feeding our ingredients into the system. So that's sort of one, we're helping the physical. On the mental, I would, or, that side of it, I might go back to the example that I showed at the beginning, which is we're trying to use some level of automation, in this case, driven by AI, to help point people, back to Michael's point, the maintenance team, to where some of the issues might be, probably are, and to basically help them target their time better, right? It's one thing to have a signal that goes in alarm and then they have to chase it down. Can we help them target their time and use their time most effectively? I think that helps them be more productive. It helps the organization, right? So there's just a couple of examples.
So I'm going to take it a little bit of a different angle, but not that much different, with Larry. So anybody in the audience wants to do this, feel free to raise your hand if you're in a manufacturing environment and you're not overtasked and you're not overworked and you've got more than enough people and you can hire people at will. And I doubt that I'd see any hands, maybe one. In our book, in the AI for Food Revolution book, I call it out. And it's not just that, it's all of them. It's all manufacturing. There's just not enough people. Okay. So rather than so much replacing people, I believe we're seeing 90 to 95% of the use cases. It's about helping people, which is what Larry was expressly talking about. It's about using, like engineers and maintenance folks aren't cheap, and their body of knowledge that they have, typically, if they cost you a sizable penny, is that, they're pretty knowledgeable. But I don't know that many maintenance folks that you can hire at will that are pretty knowledgeable. So how about us helping the newbies or the ones with a couple years to be more effective in their job, get their bonus, and stay safe and not get hurt? And I just can't say it enough over and over that it's a self-fulfilling prophecy. There's not enough people, and they're overworked, the ones we have, and overworked, too many shifts, not enough skill at times, and that leads to workplace injuries, lack of output, less scrap or more scrap, less quality. And that's why all those use cases I just mentioned, that's the ones we're actually being asked to implement AI for. So I feel very strongly about this particular topic because it's the labor pixie dust isn't going to just walk in. And it's not just here, it's Brazil, it's Germany. I read an interesting article about how low-cost countries are now offshoring labor to some other countries. So long story short is I don't think it's going to go away. And this is where AI is going to make such a great impact.
And Danae, if I could just really quickly jump on top of Michael's comment, which is that I think too many organizations still rely on the 30-year expert, right? We have the 30-year expert who knows how all the machines work, and we have to be able to give up that model for all the reasons Michael mentioned. And from our perspective, it's how quickly can we get a new hire up to speed and productive, right? And how can technology help us support that process? So I think that's critical.
Yeah, to concur with that one as well. The whole people, space, and AI displacing all their jobs. That's not the issue. The issue is how do you best and most effectively deploy those people, right? So that you get the most out of what you have. Because again, you don't have this huge overabundance of resource. So yeah, getting them where they belong. We see a lot of applications where great edge AI solutions are fundamentally taking away boring or tiresome tasks from individuals, right? Letting them focus on the things that they do well. So at least for the short term, I don't see this huge displacement coming. I see it really being a supplement as well. So yeah, definitely, Michael. Great point.
And I think even to Michael's point, when you look at countries, outside of the U.S. where it's more developing, even those countries are bringing in AI, bringing in autonomous, even if they have people, because there's an element of speed, there's an element of efficiency, there's an element of quality that goes into yield that is all correlated. So it's not just about being able to add more people; it's how efficient are you.
An element of safety as well. So the person that brought the factory or the the instrument, the asset that needs to be maintained, for example, it's that the placement on that factory is different everywhere, and the rules to get there, etc., the safety rules are different. So things like today with using mixed reality, etc., to train and to simulate before you go to the place, to the plant, on how is it that you're going to actually get to the asset in a safe way, is important as well. And all the knowledge that you need, that you may not already have, but you can train it based on, everything that's built on all the models, pushed to you through, metaverse kind of HoloLens, things like that.
And I think that's really, this is a topic I know everybody is passionate about, is how do we make sure the right messaging is shared across when we talk about AI, when you talk about autonomous and automation. Coming to that point of quality control and yield, I'll open it up panel here because I think this is another topic that I'm sure everybody wants to contribute to. Using AI, not just as a tool, like in computer vision or as a tool to detect defects, but as a tool to truly drive continuous improvement or continuous yield improvement. What's your thought? Maybe Larry, I'll start with you and your digital transformation and then around.
Sure. Well, yeah, and you spoke to the one obvious. Like I say, we're a packaging company, right? And so there's hundreds of bottles going down the line every minute and hour. And how do you make sure that every single bottle that we put in a case, is filled properly, labeled properly, even if you manage the quality of the end product upstream, right? So that's a very critical aspect for us. But then to that point, right, it's how do you get them to the next level of, okay, it's good to know when things are off spec and maybe you can even automate pushing them off the line, if you will. But how do you start to detect those things in advance? How can you use an AI model to get a much more granular analysis than anybody would ever be possible as a human? And like I say, to get out in front of those things before they become waste, before they become yield issues, right? So not only quality issues, but obviously from our perspective, that has a big sustainability impact as well, right? Because our big sustainability problems are often, right, poor filling, bad packaging, those kinds of things, right? So
I'll give you an example on the food industry, all right, that you probably like. So Grupo Bimbo, which maybe here in the US, you know it by Wonder Bread, has around 200 bakeries around the world. So let's talk about a defect. It will be, that the bread is not tasting like, it's supposed to, right? The recipe is not the right one. And improvement yield will be, using the right amount of flour, less amount of flour, or getting more bread for the flour. They are one of the largest, if not the largest, flour purchaser in the world, right? But the flour is not the same, depending on its producer and where it comes from. So the recipe for the master baker to do that bread that morning changes every day, because the bread at the end, it has to taste the same, right? But the inputs are not always the same. So they use AI because they have an AI model that takes into account where is that flour coming from, what was the temperature, when it was processed, etc. And it creates the recipe for the master bakery every morning. So at every plant, there's a recipe that is created with that AI model that very matches closely. So the fine tuning that it needs to happen, throughout the rest of the day is very minimal. And with that, they buy less flour than they need to. They produce more bread with the right flour that they have, and all the bread tastes the same. It doesn't matter in which bakery it was produced.
Real-time formulation based on changes to input parameters, essentially, is what we did there. Yeah. Oh, that's great. I know we have a few more minutes here, so I want to see if we have any specific questions from the audience. And we have one that's asking why Edge is a game changer for improving yield on the plant floor. Brant, maybe you can answer that question.
Yeah, so interesting. It is kind of a long and deep topic, so I'll try to give it the good once over here. But edge computing really kind of brings one more weapon to the data collection and management battle. We get frequently asked things like, should we go edge or cloud in our environment? We hear this all the time, but really in the end, it's not really a question of one approach or the other. It's more about selecting the right solution for the application at hand. And, it's part of why we offer so many devices as well, is to make sure that we right size the infrastructure to drive quality efficiency. So again, it's not edge versus cloud at all, but it's really the right balance of compute power to deliver the right results. And edge is really good at a few things, right? And so we really want to leverage those few things. One, low latency applications where response kind of needs to occur in real time. You want to have actions and results and notifications that happen, upon identifying some solution in hand. One, two, And probably the biggest one is the ability to optimize an application based on visual, audio, or sensory input for very, very low bandwidth operation. So essentially, avoiding sending video data across the data ecosystem and first extracting locally all of the useful information you can get from that video and simply sending the numbers, right? Don't send all that video data, just send 5. I see 5 instances of this thing occurring. It can operate locally, even with really limited or suspect connectivity, as well as in air gap facilities. It can be used to extract data while protecting personally identifiable information. I think that's kind of a big one. Everyone worries about, seeing people in the environment. Well, on the edge, it's just streaming video. You extract what you're looking for, send that data on, and all the rest of it is forgotten. And then kind of the nice piece of it that you get kind of for free is it's easy to set up. It's easy to replicate. So you come up with a good solution, you want to put it in another bay or another facility or across the country. It's very easy to replicate. You can then manage it centrally, easy to manage. And it's really quick to enable and have this drop-in IT infrastructure. So really, I'm very bullish on the opportunities edge computing can provide in smart manufacturing environments, especially given sort of the costly nature of traditional custom vision applications in this space.
I'll add to that. Going back to the question on why edge now, right? It's part of what we see at the beginning in terms of those scaling laws and those capabilities, right? Before we couldn't process, we didn't have enough power to do all that processing on the edge and just send that 5, right? It took us a lot more time. And then, so as much as we have all the benefits on the edge, now we have things like, it's an architectural discussion, but if we want some of the benefits of the cloud, like, centralized management, the security part, the provisioning, etc., and then getting the right data out and doing all the insights so that then we can do some additional things that we cannot do in the edge. Now we have things like where we can do runtimes on the edge, run as an AKS cluster. You can run that little machine that Brant has, Opera, or you can have even a Windows server or a Linux server just running AKS, having a runtime of an IoT app, and then processing whatever needs to be processed and send out to the cloud for those cloud specific things. That type of, you need the right connectivity, but that type of processing and the technology and on all the models, etc., we didn't have before. And that's now we can have more of a, we like to call it like an adaptive cloud approach, right? In which you can have things from the cloud running to the edge, and then the right things on the edge passing up to the cloud.
Thank you. Supporting that, so much of what we do is hybrid as well. So 100% there, right? It's the tools continue to evolve. They give us great capabilities, and those capabilities just every day continue to grow. And it is a combination of cloud and edge that really enables making all these things happen.
Sharing these capabilities like the Gen AI stuff, you can do now. I mean, you can probably talk to that Lexmark Ultra device on the edge, right? Show me that what you're seeing. Show me that video. You can speak to it. You can share a video. Things like that you couldn't do before. Right?
Yeah, 100%, and that's really a strong solution for us today. You used to have to build a model to identify things, and we run into occasions where someone's like, "Well, tell me when something's blocked. Tell me when my fire extinguisher is blocked." Well, it was great when you could say, "Well, I can tell you if it's blocked with boxes or pallets or whatever." If I train on said things, but if an animal wanders in and is blocking your fire extinguisher, there's no way I ever would have trained on such a thing. Today, we just simply can say, tell me if something's blocking the fire extinguisher and what is it, right? And you will get an answer, and it's generally very correct and very accurate.
Yeah, I mean, and just to wrap this Q&A around, there's one last question here come from the audience. What are the opportunities AI can provide to accelerate the time to market for new food products? So new product development, what can AI do today? And Michael, maybe that's a question that I'd like for you to take. And then why is regulatory compliance, Larry, maybe this one is for you, Why is regulatory compliance a burden for food companies? What opportunities do we have to automate that compliance? So, Michael, maybe for you, Larry, and that will be the last question we take.
Can you restate that question, please?
So what opportunities can AI provide to accelerate the time to market for new food products?
Oh, absolutely. I mean, so first off is for the manufacturers, a lot of times they struggle with being able to coordinate and being able to bring up early lines in order to get certified when they've got either changes or a net new line. And we use AI at the edge with cloud to be able to speed that up through simulation. That some people call it a digital twin. Simulation's been around a long time, but the AI can run through millions of iterations for those requirements and what those different parameters were in order to meet spec. And so that helps accelerate bringing it up to cert, right? So then the next phase of that is in terms of on the factory floor, a lot of times the changes in recipe or formulation, etc., on the process industry side changes dynamically every day. And AI is monitoring that quality and making sure that both the inputs and outputs are all marrying up properly so that you're not really waste. The waste has been drastically reduced. Those are two ways that one can help you bring up a line and a net new product or a bigger change in a product, or two, being able to dynamically alter to a product performa based on the inputs all vary, which you'd heard earlier as a use case with Bimbo, because not all corn has the same water, not all rice has the same water, depending on the type of flour that you're producing. Not all wheat has the same genome content. So, that's how we use AI.
Yeah, thank you. That's the example Charles talked about, so that's very relevant. Larry, about regulatory compliance and opportunities for AI.
So I'm not going to say anything bad about the regulatory authorities in this forum. So, but clearly the obvious challenge is obviously making sure that we can ensure quality of our products that we send all the time. And so, we talked about a couple of those where if I can prove that every bottle that goes out the door is of quality, one of the challenges sometimes we may have is if we have a quality issue and we may have to hold an entire lot of product, right? Pallets of cases, right? Until we go through the processes to confirm any issues. Whereas if we can manage quality down at the individual bottle level, as an example, right, then that's a real opportunity for us to minimize how much of that product we have to hold, for example, if there is an issue. And another one is as we get into more products that may require different regulatory needs and documentation of changes, management of change processes. How can we use AI as the means to capture those changes quickly, automatically, and minimize sort of the manual paper trail burden that often our operations team would have to work through today, which would obviously make them happier, more effective, and reduce our time to meeting those regulations. So,
Excellent. Thank you. Thank you, Larry. And what I'd like to do is kind of wrap this up and a little bit of a call for action. So thank you. Thank you to all of our panelists, Brant, Larry, Charles, Michael, for your insights, and thank you for asking the questions to our audience. Thank you for that, and thank you for participating. I want to leave everybody here with a couple of action items if you want to take that. Look at joining the AI for Food Global Initiative. This is where we want to talk about, from a food and beverage perspective, how would you like to bring AI into our journey and be a part of this forum. So look to participate. Look at joining this on LinkedIn and X. And again, a little bit of a preview to what we've done in the past. This is our forum, our annual forum, the AI for Food Global Summit. We had one this year in August. We'll be having one again next year. The audience here and our panelists will be invited to join, and looking forward participation. And last but not the least, also from that perspective, in your journey to learn, see if the book AI for Food Movement will help in your quest to learn more. And with that, I would really hand this over back to Ravi. Maybe take this home for us, if you're there.
Thank you very much, Vinay and all the panelists. Just want to really applaud all the amazing speakers and the deliberations. We did have another question, I know, but maybe I can send it to you from X, more about what skills do young people need to advance AI in manufacturing. So I know that you touched upon it, but maybe something that will be touched upon in the blog. So everybody do follow these amazing speakers. We have over 65, 75 people who have connected. We are very grateful to all of you. This will be followed up with the YouTube link to the recording that all of you will receive. Those have registered, but also it's being live tweeted out or X posted as we speak. It's also been live, I think, projected on the BCDI page. We recommend all of you to follow these, and then do follow all our amazing partners here, from Lexmark to Microsoft, and of course to Richardson Foods. Really recommend you to follow all these pages for amazing, groundbreaking, innovative work in the area of AI and smart manufacturing. And specifically, if you want to look at AI and food manufacturing, we have, Michael, Vinay, Larry, and others who are very much part of this community. So really want to thank our moderator, Vinay. Thank you so much. Thank you to Larry, to Brant, to Michael and Charles, and also people who are working behind the scenes to make this possible, Meg and Rishi, and of course, Michelle, Adam, and the team at Lexmark, who have been a co-partner in organizing this. So thank you, everybody, and do follow and look out for all the amazing work that's happening. Highly recommend you to read the book and always ask questions. Thank you so much. Thank you, everybody.
Thank you.
Thank you very much. Bye.